laboratory lessons plans opportunity created by the collaboratory. David Lowe.
Sorry, that's okay.
I am very fast.
I thought I got out of having to present. I would like to talk about lesson plans or laboratory guides or whatever terminology people choose to use. Can I start by asking for a show of hands from those who at any point in the last year, maybe 2 years, have actually gone into a physical hands-on laboratory and watched students doing an experiment and being supported and supervised? Who here has actually done that? Yeah, I would encourage those of you who didn't put your hand up to do it, because I think you learn a lot about how laboratories are used and therefore how we should be designing them by going and watching what actually occurs in that environment. And that tells us a lot about how we might design things in this particular environment. And in particular, to actually have a look at the types of laboratory experiences that do actually occur. Typically, students will be guided in the laboratory by some sort of laboratory guide or lesson plan that says, here are the things you need to do. There may be some pre-work, sort of preliminary reading. There'll be activities that they do in the laboratory. And there'll often be some form of support. There may be a lab tutor who actually helps them and gives them some sort of guidance. So the actual experience of each student, or each group of students, will often be quite different. Students will have problems at different stages and they'll get feedback, etc. Interestingly, a lot of what we have done has been, as a community, has been fairly focused on the technologies, and we've done less in terms of the pedagogic development of the guidance that we give students in using those. The technology is critically important, but it's how that technology is used which is even more important. And that the existing pedagogic research can give us good guidance in terms of, there's lots of work in areas like inquiry-based learning and situated learning that is very valuable to us. And that one of the key highlights that comes out of that literature is the significance of the individual variance between students and how you support that. So we became interested in looking at how we deal with that variation, and in particular, how we might adapt the experience for different students. Remote laboratories give us a really good opportunity to do that. Because the student experiences the laboratory through a mediated interface, they access the laboratory through a computer. That means we can see what the interaction is going, what interactions are actually occurring, and adapt the experience in a much richer way than we typically have so far. We can adapt the guidance that we're providing to the students, so we can change the instructions depending upon what they're doing. And we can even change the behaviour of the laboratory. We can hide certain parts of the apparatus, or the way in which it's accessed based on what the student is doing. We can look at the student metadata about the student, what type of student are they, we can look at how they're behaving, and we can look at what the equipment is doing and use all of that in a much richer way. So we started to explore this by encoding a set of elements to try and explore this idea. So we started off by saying we have a set of resources in a lesson plan, or a laboratory guide. When we're giving instructions to students, we might have a set of instructions as a web page or videos or images that create these resources. We also have these external domains which represent the sources of either the sources of information back to us that we can use to do the adaptation, or things that we might be able to change. And two of the most obvious ones are a learning management system that might provide us with information about the student, or where we can store results, and the lab system itself. We can then group these resources into particular, in our example we call them viewpoints. So there may be sort of a set of instructions, but there are different pathways through this guide that we give to different students. And we adapt that based on a whole set of information. So we start off providing the student with some introductory material, and depending upon the user expertise that will be stored in some form as metadata in a learning management system, we can guide them to different information depending on what type of student they are. in this, with this particular one, these little circles are the triggers that cause the navigation between the stages of the lesson to occur. In this case, this is triggered not by any external metadata, but by how long they've actually been looking at a page, and I'll come back and illustrate that in a moment. We can also have things where something changes in the laboratory. In this case, pump state. There's a piece of information about the state of the pump in a particular experiment, and when that changes, it may change some attribute in here. In this particular case, it makes a navigational link visible. So until they actually get the pump going, they can't navigate onto the next stage of the experiment. We basically built this, we encoded all of the information as a set of SCORM objects. We embedded into that the resources and a lesson structure and a set of adaptation rules that define how all of this is structured. And then embedded some script libraries that changed the behaviour of a lesson plan. The other bit we had to build were the interfaces that allowed us to monitor what was going on in the laboratory. So we defined a set of guidance like this saying, here's an API to actually query the laboratory. This probably makes more sense. If I had more time and a decent network connection, I'll give a live demonstration of this. But this is a page, a snapshot from our prototype where the student has a set of information or guidance that they might be provided with. Previously, we've often given that just to them as a PDF. We've now integrated it into the laboratory and the lab that they're actually working on. In this case, it's actually a set of hydroelectric water tanks running through onto a Pelton wheel and generating power, and then the power turns the lights in this building on, and they can explore how much energy they can generate. And in this stage of the experiment, they're sort of giving some descriptions about the water tanks, and they're told there are 2 water tanks, an upper tank and a lower tank. At the base of this is the lower tank. The upper tank is over here, and the controls down here let you move the camera around. And the instructions say here, to continue, acknowledge that you've successfully identified the upper tank. And they can either say, I couldn't find it, or I could find it. If they say that they couldn't find it, it takes them to some additional instructions, which kind of makes sense. The more interesting bit is, if they sit here and don't answer for a configurable amount of time, for 2 minutes, this page will actually change. It'll say, oh, you've been here for too long. Let me give you some more guidance. It gives them, it says, you might want to click the button over here that takes you to it and look for the thing that looks like this. Even more interestingly, if they click the button that says, I've located the upper tank, and then try to continue, the adaptation rules know whether, can query whether or not the camera has been moved over to look at the upper tank. And if they've moved it over there, it says, yes, fine, and then it gives them the next instruction. If they say, I've located the upper tank, continue, and the camera never moved to the upper tank, it says, are you sure you saw the upper tank? Maybe either you're just trying to skip ahead, or maybe you thought you did and you didn't really. So we've built an engine and a mechanism for encoding those rules that lets us create much more adaptive lesson plans that change the behaviour of what's going on depending upon what the students are doing in quite a rich way. So in essence, what that means is we've now got a much stronger ability to leverage the strength of remote laboratories, and in particular this moderated interface, but also to enrich the pedagogic elements of it so that we're not just focusing on the technology, but we're saying, how do we actually use this to change the way the laboratory is used by different students? And as a result, we get much richer student experiences in using these laboratories. This gives us the mechanism to create these sorts of adaptive lesson plans or adaptive lab guides. What it doesn't do is actually help us yet determine what types of laboratory, what types of experiences are actually most pedagogically effective. And for that, we need to go back into the literature and give some guidance about how we actually do design these laboratory guides. So, ignore the questions, I think we're skipping those, so thank you.